exponential decay. Modeling exponential decay. Carbon dating allows scientists to estimate how long ago an organism died by measuring the amount of carbon-14 in its remains, and then working with an exponential function to narrow down the results. Let's take a look at how this would work. Here is a problem. Living organisms contain both carbon-12, which does not decay, and radioactive carbon-14. When an organism dies, the amount of carbon-14 decreases exponentially with a half-life of about 5,730 years. One can measure the amount of carbon-14 left in an organism to estimate how long ago it died. What is the formula to use? The decay process can be modeled by the function A final equals A initial times 1/2 to the exponent time divided by period. But what does this mean? Let's start by identifying a variable dictionary. A variable dictionary is a list of what the variables are and how they can be applied within the formula. A final is the amount of material that's left over. This would be the sample size that's been obtained after a certain length of time. A initial is the amount of the material at the beginning. This is always 100%. 1/2, this is the rate at which the material is decaying at. Since we are dealing with half-life, half has to be the fraction 1/2. Time is the total length of time the decay is being measured over. How many years have we or do we want to find the decay occurred over? Period is the length of time that one decay cycle takes. Here is an example. Bristol cone pine fossils found in the western United States show an age of about 6,000 years using carbon dating. What percent of the original carbon-14 remain in these fossils? Now, the first step in the solution is to determine what information is given in the question. The age is 6,000 years, which is the time variable. The initial amount would be 100%. The period of carbon-14 is 5,730, which was given to us in the original explanation of carbon-14 dating. Now that we know what's given and we know the formula, let us substitute the given data into the equation given. So the final amount would equal 100 times 1/2 to the exponent 6,000 divided by 5,730. Using your calculator, solve the final amount. So you will enter into your calculator 100 to the 1/2 to the exponent in brackets 6,000 divided by 5,730, and you will get the answer of 48.4. State your conclusion. The remaining amount of carbon-14 remaining in the Bristol cone pines is 48.4% of the original amount. Here is another example. Sediments deposited by glaciers during the last ice age covered and buried layers of peat. Carbon dating shows about 25% of the original carbon-14 remaining in the peat. Estimate the age of the glacial deposits to the nearest 100 years. Here is the solution. Let's start by identifying the information that's given in the question. 25% of the initial amount remains. The initial amount would be 100%. One half-life takes 5,730 years. What is the question asking? To determine the age of the glacier deposit to the nearest 100th year. Now this time, for the solution, we will create a graph that we can use to answer the question. Creating the graph. On graph paper, draw the x-axis, the y-axis. The x-axis will represent the number of half-life periods required. The y-axis will represent the amount left in percentages. The number of half-life periods, the amount left in percentages. Now, plot the points that represent the decay. At 100%, the number of half-life periods is 0. At half-life period 1, the decay is 50% of the original, so at 1, at 50, plot a point. The half-life period 2, the decay is 25% of the original, plot this point. At half-life period 3, the decay is 12.5 of the original. And now you want to connect the dots to make the graph and add the chart title. Finding the answer to the question. Now that we have the graph created, you can answer the question by reading the values from the graph. Since the question provided the clue that 25% of the original carbon remained, find the number of half-life periods that were used. Now, draw a horizontal line from 25% on the y-axis until it meets the graph. From the point where the horizontal line met the graph, draw a vertical line down until it intersects with the x-axis. This value given here is the number of half-life periods. Now, time for some calculations. 1 half period is 5,730 years. But we have 2 half-life periods. We want to know how many years that is, so we'll use the letter X. Now we'll cross multiply. X equals 2 times 5730 equals 11460. Stating the conclusion. Now, for step number 4, state your conclusion. The glacier deposits have an age of about 11,400 years, rounded to the nearest 100 years. Don't become like a fossil. Practice your skills.